Hello viewers, welcome once again to Quest, which is the inter-school science quiz brought to you by Doordarshan Kendra Kolkata and the National Council of Science Museums. As usual, we have the director of the National Council of Science Museums headquarters, Dr. Jayanta Sthanapathy, with yet another fascinating round of questions for us. Welcome, Dr. Sthanapathy. Great to have you back again on our show. Today we have two fresh teams for you. On my right are the 𝐨𝐶 team, and they are.
I'm Shubhabrata Sen from Kendriya Vidyalaya Ballygunge, Kolkata.
I'm Rahul Chaudhary from 𝐾𝐕 Ballygunge, Kolkata.
I'm Shantanu Pal of 𝐾𝐕 Ballygunge, Kolkata.
On my left, the C.V. Raman team.
You're from La Martiniere for Girls, Kolkata, and I'm Valentina Datta.
I'm Deepanita Das.
And I'm Ananya Malik.
Okay. The rules of today's contest, fairly simple, the very same as last week. 7 questions. The first 4 are direct questions. 20 points if you get your direct question correct, and 10 if you get it on a pass. The last 3 questions are on the buzzer. Plus 20 and minus 10, that is plus 20 if you get it right, minus 10 if you do not get it right. It does not pass to the other team, whichever the team may be. These questions will pass straight out into the audience. So teams, do remember, as usual, before being trigger happy, get the answer ready in your heads. Well, more about that later. On now to the very first experiment. Now viewers, if you've been watching our show every week, you will know that the aim of our show is to provide a behind-the-scene look at why and how things work. And the thrust of our show is more education than competition. But no harm in saying, let the best team win. First experiment is for the 𝐨𝐶 team. Dr. Sthanapathy.
Here I have a double-walled aluminium channel, this one. And one side of the channel is kept at a higher level than the other end. I have 3 rings with me, one plastic ring, one aluminium ring, and one ring magnet. I'll release the aluminium ring and the plastic ring simultaneously from the topmost point of the channel. I'll do it once again for you. Both the rings reach the bottom point at the same time, no matter whether the aluminium ring is in front or the plastic ring is in front of the aluminium ring. Almost at the same point and at the same time. Now I'll release the magnetic ring and the aluminium ring together. Do they reach at the same time? No. Let us see once again. The magnetic ring takes longer time than the aluminium ring to reach the bottom. Why?
It is a revolving magnet, so
Okay.
the magnetic field are getting cut. So magnetic flux is producing. So it is there is some attraction with the aluminium channel. So it is there is some forces of dissipation. So dissipative forces are present. So it is not coming at the same rate as the aluminium is coming. For this reason,
But aluminium is not magnetic.
yes.
Why will it stop the magnet?
So because of the magnetic field created by the magnet.
Magnetic field is
No,
created by the magnet, right?
And it is also means magnetic flux is producing. So
Okay.
so for that reason, it is just getting attracted with the aluminium.
Getting attracted with the aluminium. You have any other better answer? No? Okay. Would the other team try to give a
The magnetic ring induces
Yes.
Magnetic
What
field.
does it induce?
magnetic field
Field
in the aluminium tract,
What
which
field?
we go from
an electric field
Electric field.
in the aluminium tract.
Okay.
which opposes the motion of the
magnetic
Are you
field.
sure?
Yeah.
Sure?
Yeah.
Okay, that's the right answer.
You know, a big hand. Good answer, Valentina. Dr. Sarapati, I'm sure you can tell us why, despite going through the right channels, I think J.C. Bose were not able to get the right answer.
Okay.
Yes.
As you know electromagnetic induction.
Yes, sir. That was also that was only happening in the
Yeah, but you didn't say that
You
clearly.
You didn't spell that out. The
You didn't spell
electromagnetic.
that.
Yeah.
What happens? I have a magnet here and a conductor. So whenever there is a relative motion, induced current will be produced in the conductor. In this case, the magnet is moving and the conductor is stationary. So induced current is produced in the conductor, which in turn creates magnetic field. And that magnetic field opposes the magnetic ring to roll down as fast as other objects, which are not magnet and they are not magnetic also. So the correct answer has been given by La Martiniere for girls.
Well done then, girls. You pick up 10 bonus points. And we now move on to the next question, which is your direct one. Welcome back. You're watching Quest, which is the weekly science quiz program. J.C. Bose team yet to get off the mark, but the girls from La Martiniere, which is the C.V. Raman team, are off to a flying start. They've picked up 10 bonus points, and let's see what they do with their question.
I have 3 identical glass bottles here, and they are partially filled with water. Here is less, here it is filled up to the middle, and here it's near to the neck. If I blow air inside, listen to the pitch of the sound. Now the third one. The pitch changes. Here it is minimum, here it is maximum. Why this is happening?
Okay, as the length of the air column, which is free to vibrate, changes, as it becomes shorter and shorter, the wavelength also decreases. As a result, the frequency will increase and so will the pitch.
It's a very easy question for you. Yes, the answer is absolutely correct.
Let's have a big hand for them. Dr. Stanapati, may I have a try?
Oh, sure.
I'm sure I produce a better sound. Well, La Martiniere for girls, you're producing the right sounds all right. You picked up your 20 points, you move on to 30, and J.C. Bose team still yet to score in their first innings, right? We'll be back very shortly with the very next question, which is for you, J.C. Bose team.
I have 6 rectangular wooden pieces with me. When I place them one above the other, they are stable. Very easy. Now, what I will do, I'll keep one block above the other in cantilever fashion. That means it is slightly projected. It is stable, still it is stable, though it's forming an arch. Okay? This becomes unstable. If I remove the sixth one, it becomes stable once again. Tell me why it is stable when we have 5 blocks, and why it is becoming unstable when I put the sixth one on it.
Well, we can see the teams are engrossed in a deep discussion with each other. You think, Dr. Sthanapathy, they might have the right answer?
Let's see.
All right. You must hurry up, JC Bose team.
Yes, this is because the force acting downwards.
Okay.
In case of the sixth block is getting when they are together, the force getting downward is one above the other, so that is not creating any problem. But when they are placed in this fashion, then when the sixth slab is placed, then the force acting downward is suddenly increased. It is means it was increasing, but that is not able to the stable equilibrium is disturbed. The stable equilibrium of the body is
That I
disturbed.
understand.
So
equilibrium is disturbed. But what you are saying is not correct, I am afraid. So the question goes to the...
Okay, when there are just 5 slabs, then the vertical line through the center of gravity of the system passes through the base of the structure. And so it's in stable equilibrium. When the sixth block is added, then the vertical line through the center of gravity no longer passes through the base. As a result, the equilibrium becomes unstable, and so it...
Very good. That's the right answer.
Well, is there anything that you do not know, Valentina? You seem to have all the right answers.
I think she has the completely right answer, but I'll explain once again.
Yes, doctor.
One object is in stability when its CG is passing through the base. So long we have 5 blocks here, the CG of the entire system is passing through the base. That means the block which is at the lowest point, this one. When you add one more, the CG of the entire system shifts towards the empty space that is below the arch, and it is not passing through the base. So that's why it becomes unstable. What they have said is absolutely right.
So picking up another 10 points are the girls from La Martiniere, which is the CV Raman team. Score at this stage, 40 love. You're watching Quest, the weekly science quiz brought to you by Doordarshan Kendra Kolkata and the National Council of Science Museums. We've already gone through 3 questions, and the CV Raman team have come up trumps. Let's see what they do with their 4th question, which is the direct question for them.
This is a vertical ring, and I have 2 smaller rings in it. If I rotate the vertical ring fast, the smaller rings move up to a certain height. You have to explain the phenomenon.
Acceleration is the centrifugal acceleration is maximum or something like that. It pushes them upward, and once it is balanced, once that stays there. What is balancing? Okay.
You must hurry up, girls.
Once the ring starts rotating,
Okay.
there's centrifugal acceleration over there, and because of which the rings, they are pushed up.
Pushed apart.
The smaller rings.
Yeah, pushed
Yes.
apart.
And
And they...
And once they reach that height, then what happens?
And they move to the position in which they are furthest apart.
They are farthest
Farthest
apart
apart.
from where?
From each other.
from each other.
From each other or from the center?
From the center. From the
So that's the
center.
right answer. Very good.
That's a big hand for them. I'm sure Dr. Sanapati has a far more detailed explanation
Yes,
for
I have
us.
to explain a little bit
Yes.
of this. See, these two rings are free to move, but they have come up to the central part of the ring. They didn't go above, because this is the farthest position from the center. When I rotate this, the smaller rings are subjected to centrifugal force. So normally they will try to move apart as far as possible. In this case, this is the limit. So they are coming up to this point, which is the farthest possible position of the smaller rings, and they remain here till there is enough motion, rotational motion in the ring.
So at the end of the fourth question, that's the end of the direct questions, we find JC Bose's team still running around in circles. Come on, boys, you must do better than that. The girls in the CV Raman team, which is the La Martiniere for Girls School, Kolkata, are on a handsome lead, and they've got 60 points. We'll be back with the fifth question of today's quiz, which is on the buzzer. Welcome back. You're watching Quest, and now we are into the buzzer section. Dr. Sanapati?
Here I have an elliptical board, and I have two red circular objects which I have kept at the two foci of the elliptical board. If I use one of these discs as the striker and strike it in any direction, it hits the other disc. Let me place the object on the other focus. It always hits the object which is kept at the other focus. What's the reason for this?
I don't think either team is going for that. Yeah.
Okay.
It is because after when we are striking it using one as a striker,
Yeah.
then when from one foci we are hitting, then it will as it is an elliptical board, it has to follow an elliptical path. It is means it is following after hitting the striker hits the path, then it of course comes in. It will come in the focus of the other foci. It will
But
travel
why?
like this.
But why? The curvature is elliptical. Suppose we have two foci. One is F1 and the other one is F2. I'm helping you. If I strike this object, it goes straight and rebounds from the elliptical surface and goes to the other focus.
Yes,
Now tell me why.
this is because 90 degree. It is the striker is performing a 90 degree in that region. So as semicircular that is. So 90
No, it's not necessary. It's not semicircular. This is an elliptic surface.
Have the right answer, Dr. Sanapati?
No.
Okay, I think we have to go into the audience. You'd like to answer? I think I saw you first. Why don't you come up? You are?
I'm Sheikh Wasim Raja from St. Xavier's College, Kolkata.
Okay.
When one of these circular discs is struck to this one of end of this ellipse, we can imagine one of the tangents here at this point of contact, and let us draw another normal from that point of contact. And if we measure the angle from there to this point, this angle of, we can say this as the angle of incidence, and the angle of reflection will be equal always, because the normal from that point of contact, from that point of contact will be placed such that this angle will be equal always. So this disc, when struck to any of the points, must hit this.
Very good.
Thank you, sir.
Well done, Wasim. That was very clever of you. Here's a small memento for you from Quest. Dr. Sanapati?
Wasim has given the right answer before us. But I would like to explain it once again. In this case, if we release the disc from one of the foci, and allow it to hit at any point on the curved surface, it gets reflected and hits the other disc. Gets reflected means it follows the laws of reflection. That means the angle of incidence will be the angle of reflection, just like light rays. What he has said, let us draw an imaginary tangent at the point of contact and draw a normal at that point. If you join the focus at this point to the point of contact by a straight line, and you join the other focus with the point of contact, at that point we are drawing a tangent and a normal, and you will find this angle is exactly bisected by the normal. So it follows the laws of reflection, and that is why no matter where the striker goes and hits the surface, it will come back to the other focus.
So Wasim, very much like the striker came back to exactly where it started from. I'm sure we've seen you before in our show. You've come right back to our show too. Please go back. Thank you. Give him a big hand. Well scored at this stage. The girls from the C.V. Raman team, that's La Martiniere for girls, remain on 60. And technically, 𝐶𝐤𝐳 team, you should have got minus, but we don't have anything to take from you. So you remain exactly where you were. No score even now. The next question is the second of the buzzer ones. Dr. Sanapati.
I have two pendulums here. My question is, if I oscillate these two pendulums simultaneously, what will you see?
Yes, J.C. Bose. Your answer?
The time period of oscillation is directly proportional to the length of the string of the pendulum.
Okay.
So the one with the longer length will oscillate with a greater time period than the one with the shorter one.
That's right, absolutely correct. Very good.
Come on, audience. I'm sure you can give a very much louder round of applause. They've opened their account finally. Come on, let's. Well done, J.C. Bose team. Finally seeing light of day. You pick up 20 points there, but
Now let us see whether your statement is correct or not. Yes, the longer pendulum is taking longer time, and the one with shorter length is taking shorter time. So the frequency of the shorter pendulum is higher than the pendulum with having longer thread. So your answer is absolutely right.
well, Dr. Sanapati, I hope the difference in our heights has got nothing to do with the fact that you know more about these.
Oh, no. You
No.
are not oscillating me.
I'm not oscillating. All right. So well done. J.C. Bose team, you are now finally on 20 points. And C.V. Raman team, you remain on your 60 points. Onwards now to the very last question of today's edition of Quest.
I have a very common solution in my left hand. Can you guess what is this?
Copper sulfate.
Copper sulfate. But I have acidified this with acetic acid. I'm adding potassium ferrocyanide in this. I get a precipitate which is brown in color. You have to name this compound.
Both teams huddled together, deep discussion. What do you say, Dr. Sanapati?
They are writing the equation to come to the answer.
You think they'll get the right answer?
I hope so.
Let's watch what happens.
Okay.
Both teams, you must hurry up. 𝐺𝐶 team, are you going to try? CV Raman? Not trying?
Afraid of getting minus marks?
Okay, I think we are going to go into the audience once again.
Yes.
Any takers in the audience? Anybody who's not answered a question before? I think your hand was coming up. Why don't you come up? Wasim, you already answered a question before, so we'll look for a new face. You are?
Sir, I'm Pratik from KV Ballygunge.
Okay, Pratik, why don't you come behind the desk? Look ahead.
What is this product?
Sir, this product, chocolate brown PPT,
Yes.
sir, is copper, potassium, ferrocyanide.
No, it's wrong.
Anybody else in the audience? Wasim again? Yes, please come. Take the mic.
So far as my perspective, it is copper ferrocyanide.
Cupric ferrocyanide. Okay,
ferrocyanide.
that's absolutely right. And you also get K2SO4 in the solution.
And that acetic acid
Yes.
is acting with residue K plus ion
Okay.
to produce
Okay.
potassium acetate
That's
solution.
right. That's right. So I have nothing more to add.
Well done, Wasim. How many more of these do you want now?
Yes.
Well done then, CV Raman team. That's the team of La Martiniere Girls, Kolkata. I hope that satisfies your quest for points. Let's have a big hand for them. They are the winners today. Well done. Well, you finally got some score. Did you think you're not going to have any points today? No? Don't be disappointed. Let's have a big hand for these boys too. Keep smiling. Well, that brings us once again to the end of this week's edition of Quest. Final score tally, 𝐺𝐶 team remain on their 20 points. No team brave enough to go for the buzzer. CV Raman team already had a handsome lead. They are on 60 points. We hope you enjoyed watching our show. Please do write into us with your comments. And if your school wishes to take part, our address is Quest, care of Doordarshan Kendra, Kolkata, 18/3, Uday Shankar Sarani, Golf Green, Kolkata 95. We'll see you again next week at the same time. Do join us then. Till then, it's goodbye from all of us here at Quest.